Welcome, everyone. You are here with the Sustainability Alliance for First Thursdays. We're thrilled to have you here. Today, we will be talking about preparing for climate change with Dr. Renee A. McPherson with the university. She's the university director of the South Central Climate Adaptation Science Center. So we're thrilled to have her join today. But before we get started here, I want to share just a few welcomes and a couple updates. So let's see here. Hold on just a moment, grabbing that right now just to welcome you all. Again, you're here with, thank you for attending. You're here with the Sustainability Alliance, and this month we're excited to be visiting about climate change, and we look forward to the insights and expert review here in just a few minutes on this topic. So thank you again for joining and supporting the Sustainability Alliance and sustainability in our community and your community. We're thrilled to have so many of you here interested in this topic, and we know many of you are doing some great work in your community as well. So thank you for joining. If you don't mind, please take a moment to answer some questions. I think Teresa or someone's going to throw that poll up there, and take a minute. It'll be a pop-up on your Zoom window, and take a minute. It really helps us understand how our programs are going and if they're helpful to you. So take just a moment to answer those. The programming we do bring to our viewers would not be possible without the support of our sponsors. And I want to say a big thank you to the following sponsors who help to bring that education and resources and that community connection to your screen every month. So thank you to our lead sponsor, Williams, our Neighborhood Partners Public Service Company of Oklahoma, and PSO Wind Choice, our community advocates, Cavanta, the Met, One Oak, Save Our Streams, Spirit Air Systems, Tulsa Farmers Market, Bank of the West, Camp Trevera, and Sustainable Advisors Alliance. So thank you. Give them all a round of applause. Send them a note of gratitude if you know them in the chat, because really we couldn't do it without them. And not only that, we appreciate all of their support and the work that they're doing, many of our sponsors. I also want to thank and I think Morgan's going to put some information there in the chat for you. I also want to thank the Alliance board members. We appreciate all that you do and the support to further our mission. Today we have with us Thelma Latimer Davis, Mike Teague, Nadia Kirilova, Richard Cox, and a few other board members I think are continuing to log on. So thank you to you all for joining us today. And finally, I want to thank the incredible and growing Sustainable Alliance team who work hard to bring the programming like this to you: Teresa Kerrigan, Jill Maud, Morgan Fairley, Zoe McGowan, and Missy Lukenbach. We appreciate all their work, and a round of applause to them. Really, they're just work so hard to bring all of the different aspects of what we provide. And so send them a little note in the chat and thank them as well for their hard work and all of the work that we do here at the Sustainability Alliance. You can also become a supporter. This is another way that we bring this program to you. And you can become an individual supporter with the Alliance. It's quick and easy. We'll put the link in there, but it's just $25 to add your name to a growing list of change makers. So we'd love to have your support. Helps to further our sustainability education, Bellman Awards, Sustainability Awards, First Thursday events, B2B Case for Sustainability series, the Scorecard program, and now the TerraScore app, and so much more. So we'd love to have your support. Anything would be really helpful, and we appreciate everyone's contribution. You can also see that the Sustainability Alliance has a Facebook group to help better connect our community. If you'd like to connect with the sustainability-minded folks, this is a great way to do that. And Teresa will put that link in the chat. Make sure to join the group chat for real-time updates and insights. And now I'd like to say thank you to some of our sponsors today. So we'll start with a video from our lead sponsor, Williams.
At Williams, we're focused on adding new technology and operating practices that deliver right here, right now reductions in global emissions, cutting-edge emissions measuring and monitoring, certifiable and transparent emissions data, real-time energy optimization across the natural gas value chain, integration and delivery of the fuels of the future, meeting global energy demand and global climate goals. For us, this is just the beginning. Williams, we make clean energy happen.
And thank you to Williams. They have been our lead sponsor for the last couple of years. So we really appreciate their support and the work they're doing in sustainability efforts as well. Next, we have our neighborhood partners, PSO, who wants to share with you information about their solar calculator and rebate opportunities. So visit them online to learn more. You can also reach out to Carrie Rowland directly at krrowland at aep.com. So lots of good incentives and opportunities there. So reach out and find out more. Next, we have the Met, MET. They offer recycling services throughout the year in the Tulsa area, and you can here in Oklahoma, and you can drop off sites there where you can drop off your recyclables. They proudly provide meaningful employment opportunities for individuals with disabilities. So find out more about visiting them at metrecycle.com and the great work and education they're doing. I also want to thank Save Our Streams as a City of Tulsa department that promotes healthy waterways and pollution prevention through their stormwater quality programming and their environmental inspections and household pollutant collection events and facilities. So they offer a variety of services to help you with your streams. So get in touch with them at stormwaterquality at cityoftulsa.org. And if you're not in the Tulsa area for recycling and for stormwater quality, reach out and find out more what's in your area and get involved there. Also, if you're curious about carbon footprint of your purchases, the carbon footprinting of it, Bank of the West exclusively offers their services through their mobile app and donates 1% of their net revenue from their bank account to 1% for the planet at no cost to you. Questions? Want to sign up? Call Eric Anders at 918-877-4577. And next up is our Tulsa Farmers Market, another sponsor of ours, and which takes place every Saturday now from May through November. They kicked off last week, and they're in the Kendall Whittier district. The spring market is an exciting time for you to grab the local foods and meet your farmers and producers. So we encourage you to get out there and either visit the Tulsa Farmers Market or the farmers market in your area. Great way to get to know some of your sustainability folks in your area. And last but not least, our Sustainable Advisors Alliance, an innovative co-op financial advisors group that can help you manage your investment portfolio in a sustainable manner and provide solutions for your profit bottom line. They offer no minimum requirements to start investing your dollars today. So get in touch with Julie Skye to learn more by visiting her website. So thank you again to all of our sponsors and all that they do to be a part of the sustainability community. Next, I'd like to introduce our speaker today, Dr. Renee A. McPherson, who is bringing her years of experience and passion in the climate action space to today's discussion on preparing for climate change. Dr. Renee A. McPherson is an associate professor of geography and environmental sustainability at the University of Oklahoma and the University Director of the South Central Climate Adaptation Science Center. She holds a BS in mathematics and a BS and MS and PhD in meteorology. Her research includes the societal and ecological impacts of climate variability and change, regional and applied climatology, and severe local storms, which I think we had one just recently here in the Tulsa area. She teaches classes in climatology and physical geography and advises graduate students in their research and education and mentors undergraduate students who are interested in research opportunities. Formerly, she was the state climatologist for the Oklahoma and acting director for Oklahoma and the acting director of the Oklahoma Climatology Survey. In January of 2019, she received the Charles E. Anderson Award from the American Meteorological Society for her extraordinary sustained efforts to broaden participation of traditionally underrepresented individuals in STEM research and education, particularly women and Native Americans. She also serves as the lead author of the Southern Great Plains chapter of the 5th National Climate Assessment. So welcome to First Thursday and the Sustainability Alliance, Renee. We're thrilled to hear from you today.
Thank you so much, Corey. I appreciate you and all the work that your team has put into this. I'm going to share my screen and we will get started.
Okay, and I think Zoe, you have to stop sharing and then she will share.
Can you see my screen now?
Yes, looks great.
All right. Wonderful. So thank you and hello to everybody out there. I'm happy to chat with you today on this important topic for everyone on our beautiful planet here. Before I start, Corey talked a lot about me, so I'm not going to spend a lot of time on the slide, but I'm originally from Wisconsin and came to Oklahoma in 1987 for my graduate studies. I met my husband in graduate school, and he's a native Oklahoman. And we have stayed here working in this fabulous weather and climate community ever since. I also am very honored to have been teaching classes to people like Megan Fairley, who have gone out into the world and done fabulous things. And so one of the things that excites me the most is working with brilliant young students turning into brilliant young workforce. So I'm here to talk about climate change, and I know that can be a polarizing term to some, but I'm the expert in the science, not in policy. So I'm going to be frank with you on what the science is telling us, and then you can decide how to respond. So I'm not going to focus on day-to-day weather, but on these long-term changes over decades. And scientists do know that there are many natural causes of climate change. However, with the exception of meteor impact, for example, these natural changes occur over thousands to hundreds of thousands of years. And essentially, natural climate change does not happen during our lifetimes. So I'll be looking at the time frame that our atmosphere changes over our lifetimes and the lifetimes of children today. So we're going to focus on human-caused climate change. Now, we have known for over 150 years that carbon dioxide is a greenhouse gas, and too much of it will warm Earth's surface. So if Twitter existed back in the 1800s, we would have seen tweets like this, where people are mentioning that this does occur. So this is not a recent understanding in the scientific community. This is science that we know well. So we know that incoming visible and ultraviolet radiation are transparent to the carbon dioxide and other greenhouse gases in the atmosphere. So it makes it to the surface to warm our land and our oceans. But when Earth re-emits radiation, it emits it in what's called the thermal infrared. And these greenhouse gases absorb very heavily in the thermal infrared. And so it's absorbed in the atmosphere, where that energy then warms the area. And then the energy also is returned, about half of it back to the Earth's surface, adding extra warming to the surface. And this natural process of the greenhouse effect keeps us alive. So it's a great thing to have. But, you know, just like food, we need it and it's good for us, but too much of it can turn into being a bad thing. So when we add more greenhouse gases into our atmosphere, extra heat is trapped and our surface temperature will slowly warm. Now, scientists have measured the increase in greenhouse gases since the start of the Industrial Revolution. Carbon dioxide, methane, and nitrous oxide and other greenhouse gases accumulate because they have long residence times in the atmosphere. So they can stay in the atmosphere for decades or centuries. Another powerful greenhouse gas is actually water vapor, but water vapor circulates throughout the atmosphere just in a few weeks. So it doesn't accumulate like carbon dioxide, methane, and nitrous oxide. And we usually focus on carbon dioxide just because it's the largest contributor of these extra greenhouse gases, and it's predominantly from fossil fuel use. And we can chemically determine that this added greenhouse gases, the carbon dioxide, nitrous oxide, and methane are from human activity, primarily as the burning of fossil fuels. So on the left side shows our global carbon dioxide budget, and carbon dioxide is a natural component of our Earth system. We have natural sources of carbon dioxide like forest fires or volcanic eruptions. And we also have natural sinks of carbon dioxide like our vegetation, our plants across the world, and our oceans. But human added carbon dioxide is too much for our oceans and our ecosystems to absorb quickly enough to keep up. And therefore, about half of the human added carbon dioxide is removed by plants and oceans, but the other half accumulates in the atmosphere, which you see in the diagram on the right. And it's this accumulated atmospheric greenhouse gases that are leading to what we call global warming. So we can compare the global monthly temperatures to the average global monthly temperature from early in the record. So this starts in the late 1800s and it moves every month forward. And so we can see what the anomalies are, whether they're warmer than normal or colder than normal. And what we saw is the beginning of this record, about half the months were warmer than normal and half the months were cooler than normal. But as we move into the months during the lifetime of today's college students, we see very few months that are at or below the previous average global temperature. We also know that over the past 150 years, where our observational record is the best, that the 8 hottest years have occurred during the lifetime of today's 8-year-olds. So if you know an 8-year-old kid, they have lived their entire life during the 8 hottest years in our 150-year record. So it's not only temperature that indicates that, but there's a lot of other indicators that our world is changing, and we lump these all together into this term climate change. So these can include things like melting snow and ice, warming oceans, changes in the length of our growing season, and changes in how species move or reproduce. So some of these effects are indirect, and scientists are still researching like how certain species are responding to these physical changes in their environment. And other effects are very direct and exceptionally well researched, like sea level rise. And I'm happy to share more with you, but because time is short, I'm going to kind of transition and start talking about what will be happening in the future under different types of scenarios. So for decision makers to do their jobs, they need to know what might happen in the future. You can't prepare. So climate scientists use the laws of physics that we get in our schooling to build what are called computational models that use computers. And this is computational models of our our climate system, our Earth system, and we use those then to project into the future. So these so-called global climate models are not intended to predict a specific event at a particular time or a particular location. The results are general trends over time and large scale regional patterns. So we, as climate scientists, we verify these global climate models by running them in the past, like in this simulation. So this simulation is just an example of one global climate model and one variable output from that global climate model. In this case, our water vapor field. So we can see kind of where clouds are. So without forcing this model with any historical data of the model generates what we know happens with our weather patterns. So we see things like the jet streams and the intertropical convergence zone and tropical cyclones. Those are just automatically generated by placing the continents and ocean and the radiative forcing and the composition of the atmosphere into the model. And what we've seen is that these models satisfactorily depict the past climate. And since we know physics doesn't change, we can then apply these models to possible future scenarios. So on the left is an example of some scenarios. So future scenarios anticipate possible pathways that countries around the world could take between now and the end of the century. And we use these scenarios to help planners assess their future risks and opportunities. So one scenario shown by the RCP 8.5, and this is a scenario that represents the world where fossil fuels remain our main source of energy, and countries like build their economies. And so sometimes RCP 8.5 is called the business as usual scenario. Now the green line shows what's called RCP 2.6, which is sometimes referred to as the peak and decline scenario. And this is where greenhouse gas emissions are reduced significantly over the next few decades and remain reduced. We actually go below net zero in the future scenario. And so we take these scenarios and climate scientists input the atmospheric forcings associated with them into their model for months on the world's largest supercomputers. And then we can output things like temperature or precipitation and look at the resulting patterns. And so what we see on the right side is the globally average results of that process. And so what we see is in the RCP 8.5 scenario, or that business as usual scenario in the red, from multiple models led by multiple countries around the world, that the global average temperatures are projected to increase between about 3 and 5 degrees Celsius, or about 6 to 9 degrees Fahrenheit above pre-industrial times by the end of the century. Using RCP 2.6, or the peak and decline that's in the green, we remain below 1.5 degrees Celsius, or about 3 degrees Fahrenheit above pre-industrial times by the end of the century. Now, those graphs are great, but not nearly as helpful as a nice map would be. So we can take these global climate model results, we can map them. And in this case, we see a mid-level scenario on the left and the business as usual scenario on the right. And we see that in both of these cases, that the projected change in annual average temperatures is going to be toward increasing temperatures for either scenario out to the end of the century. And so that we get significantly warmer temperatures for that high emission rate. Global climate models give us a good idea of the kind of the large scale patterns, in this case for North America, for our future climate. But most decision makers want more detail per specific region. And so what we do is we do something called downscaling, and downscaling for local results. I'm going to show you some of the downscale projections for the South Central US that were produced by my center. And I'll talk about them, mostly focused on Oklahoma. But what I and groups across the world do is take the output from these global climate models, and our center uses the historical global climate model output and actual observations that we have over multiple places across our region. And so we take those relationships and we say, okay, if those relationships remain similar in the historical period and out into the future, then we can apply those relationships to this global climate model data and then work that back to a more localized or downscaled regional projection. So the funders of this work include the USGS, the National Oceanic and Atmospheric Administration, the National Science Foundation, and the University of Oklahoma. And the projections that I show here and many more are available at our website at southcentralclimate.org. So all of the maps that I'm going to show you kind of have this similar pattern to them. So let me walk through what you're seeing. First, all of these maps show the average of 27 projections that we used for each of the scenarios. On the left is the RCP 2.6 scenario, that peak and decline scenario, and on the right is the RCP 8.5, or the business as usual scenario. So we'll call that the low scenario and the high scenario. Each map displays projected change in a particular variable. So this change is the difference between the future period and our recent past, in particular 1981 to 2005. And for these maps here that you see, the future period is the mid-century. So that's from about 2036 to 2065. So this particular map shows the projected change in the annual average high temperature by mid-century in the peak and decline, or the low scenario on the left, and the business as usual, or the high scenario on the right. And what we see is that average daily high temperature is expected to range from about 3 to 6 degrees Fahrenheit warmer year round when compared to the recent past. This is the same thing, but a projection at the end of the century. And in this case, we are seeing really some substantial differences between the low and the high scenario. The annual average high temperature is projected to be about 3 degrees warmer than our recent past in the low scenario, whereas the daily high temperatures are expected to be almost 10 degrees warmer on average every day of the year in the high scenario. And the difference between these two projections results from our choices, primarily in what we eat and what type of energy we use. This is the average daily low temperature, and we see that those two are expected to warm about the same amount by mid-century as what we saw for the daily high temperatures. By the end of the century, the daily low temperatures are projected to average anywhere from 2 degrees Fahrenheit in the low scenario to closer to 8 degrees Fahrenheit warmer in the high scenario. And these temperatures are really important for public health because our bodies need to rest at night from those hot daytime temperatures. So warmer nighttime temperatures reduce our body's ability to rest, and especially influences the health of those people with chronic diseases. Now, if we look at extreme heat days for the mid-century, we find that in the low scenario, Oklahoma is expected to average about 10 more days above 100 degrees Fahrenheit than in the recent past. However, in the high scenario, projections show an average of 20 to 40 more days of 100 degrees or more. And that depends on where you live in Oklahoma. Again, the difference between the two scenarios results simply from human choices, as the physics is staying the same regardless of the scenario. Now, one last projection on temperatures that I want to show you kind of really emphasizes the long-term nature of decisions today, both personally, in our community, and in our businesses. So these maps are the change in the number of 100-degree days by the end of the century. And what we see is that for our children and our grandchildren, they may only need to deal with 5 more 100-degree days as compared to today, if the countries around the world focus on cutting greenhouse gas emissions quickly and substantially by the next decade and beyond. However, if countries continue to grow in their use of fossil fuels, then we project that our grandchildren will have about 2 months more of 100-degree days on average. So for any year, on average, there will be 2 months more of 100-degree days. So I just want to be clear on that. Right now, depending on where you are in Oklahoma, you average about 5 to 10 100-degree days. Add 2 months more of that, and that's what we mean for the end of the century. And we have high confidence in these temperature projections. They are consistent regardless of global climate model or downscaling method that is used, and the physics relationship between absorption of energy and the increasing temperature is very direct. So clearly our choices today matter greatly for our children and our grandchildren. Now I'm going to briefly look at precipitation. This product shows the projected change in average yearly precipitation, so the total precipitation in a year, and the values are the percentage change from the recent past to the mid-century. So negative values mean that the total annual precipitation is projected to decline in the future. And our annual precipitation may affect how much water is available in our lakes, but usually people care more about the timing of precipitation or the intensity of precipitation. So this product may not be as useful as the annual temperature map was. And we have many other projected products for precipitation that I don't have time to show today. So the low scenario shows essentially that there's not much of a change in our precipitation total if we head down the low scenario for the mid-century, but we get a slight decrease in our annual precipitation, mostly in the western parts of the region by the mid-century in the high scenario. By the end of the century, again, a similar story. There's very little change, especially in Oklahoma. annual precipitation in the low scenario, but we do get a consistent drying in the western part of our region. So if you go to our website, you can get many more precipitation products, like the length of dry spells or number of days of precipitation over 2 inches. But what I know that you're eager to know is what can be done about this. So this is an all hands on deck moment for us. There are tremendous opportunities to choose what we want our communities to look like in the future and to work together individually in neighborhoods and in businesses to aim at this goal. So everyone has a role, but everyone's role will look different. So don't judge somebody else's role compared to yours. So I give you some examples of what can be done at home, in the workplace, and around our communities. And these are just a handful of options. There are hundreds of them for climate adaptation and mitigation. So first, let's look at where and how you live. So in your home, look for opportunities to reduce your energy and water consumption. For example, perfectly manicured lawns reduce that biodiversity that's needed to maintain healthy ecosystems. Also, if you have a pattern of watering your lawn and then you have to mow your lawn more often because you watered your lawn, let's try to reduce that pattern. Similarly, we can talk about grocery shopping. So moving food from across the world, like pineapples don't grow in Oklahoma, to your grocery store is energy intensive. So this is a way you can support your local growers and eat local foods. And then really make sure that you find places where you can spend some more time with nature to understand better how nature is something that gives us a buffer against some of these climate extremes that we expect to see. Now at work, these are important places where we can practice new habits and then bring them home with you. So businesses are also critical to helping communities prepare for, respond to, and recover from climate hazards. So something important to do, especially after a disaster, in the recovery efforts, is to hire local workers to keep those people in your area who were affected employed. And we need to make sure that we train workers that are in declining industries like oil and gas with the skills that they need to help build healthier communities and exciting new futures with different types of jobs. The real work in climate mitigation and adaptation is not happening at the national or international levels. It is happening in communities all across our world. So residents can gather together to imagine what their community will look like in the future, thinking about what actions align with their values and their long-term goals. And the examples here are just a small sampling of what others have done to work their way toward their goals of being a safe, sustainable, livable, and vibrant community in the face of climate change. And I know you didn't have time to scribble down all of these examples, but you really don't have to. By this November, the 5th National Climate Assessment will be made public, and there are hundreds of examples of successful mitigation and adaptation stories or methods that are used across the nation. I'm the lead author of the Southern Great Plains chapter, and I have a fabulous author team and technical contributors from across the region. This team includes experts in the impacts of climate change on our region, and also experts in mitigation and adaptation at the local level. Just yesterday, I returned from our all authors meeting that we had this for the first time, everybody together. this week. And I can tell you that this assessment report will be the best one yet. It will highlight more than I can do here. But let me give you a little bit of a sampling of Southern Great Plains. So we have 5 key messages in the Southern Great Plains chapter, and I really wish I could share them with you, but we're not allowed to be specific about anything in the report until after the public release. But what I can say is that we do focus on people and businesses and communities and the things that across Kansas, Oklahoma, and Texas that people actually value. So it's specific to our region. We also examine how climate change is projected to affect how we live, how we work, how we play, how we heal inequities and injustices, and how we serve through public services and infrastructure in the region. And we've examined the research that's specific to our region, and our adaptation professionals on the team have helped us craft our content so that it will be usable. The document has been reviewed by the public, by government agencies, and by the National Academies of Science, Engineering, and Medicine. And we have to respond to every comment, and we are transparent about the choices that we made in all of the chapter content, and that goes for every chapter. So be on the lookout for the public release of the 5th National Climate Assessment this fall. And thank you so much for listening. I'm very happy to answer any questions.
Well, thank you very much, Renee. Lots of information and lots of concern. I'm sure we're seeing in the chat, just concern, but also appreciated that you offered things that we can do. And I saw some of my team sharing there in the chat, like scorecard and TerraScore, definitely ways to kind of support your list of ways that we can come together as communities. But I know that, so if you have any questions for Dr. McPherson, please put those in the chat, and we'll definitely be glad to help bring that out. So it looks like Rebecca says, can you describe the impact to people on what a +1.5 Celsius actually means? What would that mean? And especially if you get to 10 plus.
Right. So essentially the best that we can do now by the end of the century and throughout our century is this 1.5 degrees Celsius or 3 degrees Fahrenheit on globally averaged temperatures as compared to pre-industrial times. And what that will mean is that we'll still be seeing more extreme events, especially in this region of the country. We'll be seeing more heat waves, more high intensity precipitation events, which tends to, with our clay soils, cause some flash flooding. We might see a shift in where severe thunderstorms are occurring, but more likely we'll see a shift in the season to a little bit earlier than we have in the past. Our growing seasons will lengthen. We have to adapt to that, but that adaptation is doable. There's a report that compares the 1.5 degree Celsius mark to just 2 degrees Celsius. So just looking at what that additional 0.5 degree Celsius would mean worldwide, and not even talking about that possible 9 degrees Celsius, for example. And worldwide, we're talking about billions of more people suffering with heat waves if we hit 2 degrees Celsius as opposed to 1.5 degrees Celsius. We're looking about 75 million more people around the world affected by drought each month. Tens of millions more people around the world exposed to water scarcity. Millions of more people, including in our part of the world, being exposed to river flooding with increased fatalities. We're seeing we're expected to see larger areas of major ecosystem shifts. So we already see this in the western part of the United States with these mega forest fires. So we would see much more of that in our region, larger and more often these mega grass fires that we have seen periodically in our region. And so these are pretty, just with that additional 0.5 degree Celsius, these are pretty concerning and dramatic instances. There are people who are living on low-lying islands now, for example, in Fiji or other parts of the South Pacific, that their islands essentially would disappear if we move to the 2 degrees Celsius. And so this is why it's just really so critical for us to talk about this now and to really dig in hard and fast for solutions. But the nice thing is a lot of these solutions are completely in line with where we want to go already in the future. So do people want cleaner air? Of course they do. So solutions to climate change also are solutions to cleaner air and cleaner water.
Thank you very much. There's a lot of questions are coming through. One question is, how does this affect the farming industry, the impact of climate change and our food systems and feeding the world? Are there any projections on how it will impact our food systems?
Yes, so great question. So if we look at crops like winter wheat or cotton from our region, so cotton's a very water intensive crop, and the resources, for example, in the Ogallala Aquifer, the amount of water that's there is much more reduced. And there's a question about whether cotton can grow in our region beyond the next 10 or 15 years. Winter wheat in our region, which is where we not only get a crop, but we also graze livestock on these winter wheat crops during the winter time to reduce the cost of bringing in hay. That's a rain-fed crop, which means that as our weather gets, whatever term you call it, weirder, funkier, less predictable, then we are likely to see more seasons where we have crop failures in parts of our region. And so this is certainly an area that we've been very concerned about. Heat stress on poultry and cattle and hogs that are throughout our region is a major concern. And not only that, but that heat stress we project will be accompanied across much of our region by increasing humidity, especially in the eastern half of our region.
And also what I'm hearing when you're saying that, I actually happened to visit the Wichitas this last weekend and drove through where some of that cotton is produced, and just thinking how that'll impact those families if that was their sole source of income. And so it's really a domino effect. And that's, kind of crushing, thinking about those families. So many other questions. One that came through is, if you could talk about what the albedo cycle is and, how that will impact, kind of what you're talking about.
Right. So a lot of times we say, people think, oh, what happens way up in the Arctic doesn't matter to Oklahoma because it's far away. I've never been in the Arctic before. But what happens in the Arctic is really important to us and to the rest of the Northern Hemisphere. So the ice and snow in that region reflect a majority of the incoming sunlight, which means that it keeps that area of our North Pole region cooler than it would be if we removed all of that ice and snow. And so in a warming world, we are now removing much of that sea ice, and the what's called the albedo, or the reflectivity of those areas now is decreasing, which means more of that solar radiation is being absorbed at the surface. So what we have been seeing is that the Arctic is warming 3 to 4 times faster than anywhere else on the planet. And so if the tropics are warming a little and the poles are warming a lot, then the change in temperature, the difference in temperature between those two regions is becoming weaker. And that affects our jet stream. And the jet stream is what it brought the cold front here the other day to Oklahoma. So when you have a weaker jet stream, the jet stream becomes wobblier or less predictable than when you have a nice, really cold Arctic. So that means we get storms or heat waves or even extreme cold waves like in February of 2021 more often than what we do in the past. And so it's really hard to live in a climate where things are even more variable than what we're used to in this part of the region. So that's why that's really important.
Right. And you spoke about, that we're already adapting. I know that when I was a kid, and planting seeds, like we changed our zone even within my lifetime. And so we're already starting that process. Can you speak a little more to that and the work that you're doing? How much of the information out to individuals and corporations is about focusing on that as opposed to mitigating, and where you see the importance of that conversation and how we can, and there's many people on this call today that are very active in working on some of these issues. So I think that it would be helpful to hear some insight on that.
Yeah, so great question. So adaptation and mitigation now have to go hand in hand. So had we, when we first realized that climate change was occurring and we were needing to respond to that, had we mitigated heavily at that time, then we wouldn't kind of have some of this climate change already baked in, which we have now. So there is some of the climate change that's baked in. We already know that at best, we're going to be a 1.5 degrees Celsius, or about 3 degrees Fahrenheit, averaged over the globe warmer. And so we have to do adaptation. So, what adaptation looks like in many places is based on what that region has seen. So if you have been prone to floods like Tulsa has in the past, those floods, those heavy rain events are likely to become more intense. So more rainfall in those events when they happen. They may happen more frequently. They may happen at times of the year that you're not used to them happening. And so we just have to prepare and adapt in those cases. But the key here to make sure that our future is something that we, depending on how long we live, and our children and our grandchildren, don't have to, in a sense, reconstruct what society actually looks like. We have to do mitigation. We have to do it extensively, and we have to do it quickly, and we have to be brilliant about it. And that's what people in Oklahoma and beyond in our region are really exceptional at doing that. And we see that with all of our energy companies in the region. They used to be solely focused on oil and natural gas. These are now becoming energy companies with portfolios that include renewables and low carbon solutions. But some of the quickest things that we can do on the mitigation side are reduce our consumption of beef, because beef is a methane heavy production. We can also seal leaks in natural gas lines that releases an inordinate amount of natural gas or methane to the atmosphere that's not used, and methane disappears from the atmosphere after about 10 to 20 years. So if we can reduce our methane emissions as quickly as possible, that will be the first big step. And then we can focus on reducing additional greenhouse gas emissions. So I'm hoping that I answered your question, but if you have a follow-up, happy to.
Well, we might take the follow-up as we want to just kind of honor the time here. And I know there's lots more questions, and I'm sure we'll invite people to stick around for a little bit longer if you can stay with us to let people ask some questions. But again, thank you so much for helping to explain these very, complicated and connected activities and the role that we can play individually. And I know you mentioned some of the things that our communities, some of our businesses and other partners can also play. And I think it's always important to have a level of hope here, because it can feel very overwhelming and like, why does it matter? And I think that if we are working in concert together and doing these things that we can all do, there's simple things that we can all do, and bigger ones, of course, as a community. So thank you for offering that as well, because that sometimes it's hard to get out in these types of conversations. So I really appreciate that. You've got a lot of fans, by the way, Renee, that have been sitting in the chat and here with you. So let's give her a round of applause. I wish she could hear it all, because I know it would be huge. And thank you so much for your time and the work that you do. Very important to helping us really understand some of the things that we're up against and what we can do right now. So thank you very much. And thank you for sticking around just a little bit. So we just launched our poll of our exit poll. So please take just a moment there. And again, thank you all for joining us and for your thoughtful questions. We'll try to answer a few more of those here in a minute. But as we're wrapping up, again, take a moment to take that poll. But also wanted to let you know we are launching a program, a pilot program this year. We are working with Rabbi Boone Mark Fitzerman to help us kick off a First Steps program, and that's for faith-based communities. So if you have an interest in sustainability and part of faith-based community, we'd love to hear from you. So send a note, send an email to Missy at the Sustainability Alliance, and we'll I think that'll be thrown there in the chat to help you out there to connect with her. Additionally, if you're here today and you're a member of Scorecard, for those who are not, Scorecard is our program for organizations to track and improve their sustainability efforts. So a lot of things that Renee spoke about today, you can find there. So there's lots of good resources there, as well as our TerraScore app. So there's so much that we do have a part of what we do here at the Sustainability Alliance to support you on this journey to help improve our community and to really address these things that you can do today. So reach out to Teresa Kerrigan as our scorecard director. Her information will be thrown there in the app. Reach out to her today if you would like to learn more about our scorecard program. And then also you can see here that you can sign up for the app there. So if you haven't already, scan it. Lots of great information there. Love for you all to participate in that. And also wanted to congratulate our first challenge winner, Small Steps for Big Impact, Renee M, with the Gathering Place. Congratulations. She had the highest score there, and she won a package of our branded gear and some LED light bulbs. So keep an eye, congratulations, we'll get those over to you, and keep an eye out for our next challenge and compete to win and make a difference like Renee did. So thank you for all the things that you were doing there. And finally, we want to invite you to our May 1st Thursday. It'll be about local biodiversity and the focus on monarchs and our pollinators. We do that every year, very important. And so we'll have some more information about that, but it'll be May 4th here online. So we hope to see you. And we'll have some other opportunities too. In May, we'll also have our B2B Case for Sustainability series. It'll be our kickoff for this year, and we'll be focused on solar. So we'll have more information out in the next week, and invites will go out. So we hope that you can join us for that. But it's really about kind of understanding and discussing from sustainability from a variety of perspectives across a wide range of topics and for the B2B, but this one will be on solar in particular. And for companies and organizations looking to adopt a form of renewable energy, no matter the scale. So join us, we'll be at River Spirit Casino, and thank you to Muskogee Creek Nation for that sponsor. And that'll be May 18th, Thursday. Great networking and learn. And if you happen to not be able to come to Tulsa, we'll also have some online opportunity there. So anyway, thank you again to our sponsors, to Williams, Public Service Company of Oklahoma, PSO Wind Choice, our community advocates as well, Cavanta, the Met, One Oak, Save Our Streams, Spirit Air Systems, Tulsa Farmers Market, Bank of the West, Camp Trevera, and Sustainable Advisors Alliance. Thank you very much for your support of today's program. We look forward to seeing you at our next First Thursday on local biodiversity with the emphasis on monarchs. So be back here on Zoom on May 4th, and we'll see you then. Thank you so much, and stick around if you have a few more questions or want to just visit. Thank you again.